welcome back to another exciting episode of Algebra 1. I'm just kidding, it's probably not exciting for you, but today we start something new. We're starting quadratics. This will be the part 1, the first lesson is one way how to solve it. There are several ways building up to the quadratic formula, which is what we're going to end on the school year on. And the first way you've actually already learned, you just didn't know that's what you were doing. If you're in my class, we're on page 308 to 310. This is quadratics, solving by factoring, which we've done factoring before. We spent about a month on all the different types of factoring, and at the end we learned to solve by factoring. The steps mainly are to move everything to one side in standard form, ax squared plus bx plus c. That just means the x squared needs to be first, the x term, and then the regular number. Okay, factor it however we need to factor it, and then set each one of the parentheses that you get from factoring equal to 0 and solve. Alright, there's also a check, but we're not going to spend the time on the check right now. We're going to spend the time on the process. I'm playing a little bit with the camera views, so I don't know if I'll be off video or not. I'll still be talking, but I was trying to play around with the lighting and the glare to change the glare. And I noticed on some videos yesterday when I stood over here, I blocked some of the lesson. So I'm going to try to stay out of the way and get focused. Alright, so this is on, the work is on page 310. And you have problems, but they won't be ready to factor because everything's not on one side. So one thing you want to know, that your x squared term or whatever squared term you have, whether it's a y or an m, it needs to be positive, not negative. So if you want to move everything to the side where it stays positive. If not, you have to divide everything by -1, which is just extra work. So in this case, my 3x squared is positive on this side, so I'm going to move 5x over, just like we do in regular algebra. It's positive, so I'm going to subtract it. I'm going to get 3x squared minus 5x equals 0 because I moved everything from that side. Alright, that is my first step. Now, I don't have a c, I don't have a regular number. That's okay. I don't need to put plus 0 over there. It's fine. And I'm going to factor this. Well, there are only two terms, so this is either a common factor or this is difference of squares, because difference of squares is the only one that deals with a binomial or two terms. Well, 3 is not a perfect square, neither is 5 or this x, so it's not a difference of squares. This is just common factoring. So in 3 and 5, they're both prime. There's nothing that can be taken out, but x squared and x share an x. So I can take an x out, which will leave me 3x because I took one of them, minus 5 because I took that x, equals 0. Now I need to set these equal to 0. Now this isn't in the parenthesis, but I can set it equal to 0, but I don't need to solve because it's already there. But the 3x minus 5, I will set equal to 0 and solve for x to get the other answer. So I move this 5 over because it's subtracted, and I get 3x equals 5. I divide by 3, and x equals 5/3. So these are the two answers I would get here. Okay, so it's not unlike the solve. It's exactly the solve by factoring that we did a while back, if you can remember it. If not, flip back to the pages. I also gave you a little factoring packet that breaks down each type. The biggest issue you're going to have is to figure out what type of factoring that you need to do. So, all right, moving on to number 9. Number 9, the x squared is over here, and all this is on this side, but x squared is positive, so I'm moving everything to that left side. So I need to subtract 16x from both sides, which is going to give me x squared minus 16x equals -64. And since that's a -64, and I'm going to draw a line here so you don't get confused here. This is -64, so I need to add it in order to move it, because we do the opposite. And I'm going to get x squared minus 16x plus 64 equals 0. Alright, Now I have everything and I can factor this, okay? This has 1, 2, 3 terms, so it's a trinomial, which is what we deal with mostly in factoring. If there's nothing in front of this x squared, you're not going to be able to factor out a number. And then this one doesn't have an x, so I can't take that out, so it's not a common factor. This is what I consider an easy trinomial, or the quadratic trinomial, where there's not a number in front of here. So you can say what multiplies to this and adds to that. Now, this may be a perfect square trinomial, which is a shortcut. However, I'm going to do it the easy trinomial way, because even if you don't know the perfect square trinomial, you can still do this. So you get 2 parentheses, and you say square root of x squared. That's the first thing. What multiplies to give me positive 64 and adds to give me negative 16? Well, I'm going to go with 8 times 8. But in order to be positive and negative 16, when I add them, they both need to be negative, because negative 8 plus negative 8 gives me negative 16. But negative 8 times negative 8 gives me positive 64. So these are going to be minus 8. So that was a perfect square trinomial. Now I take these and I'm going to set them equal to 0, but they're the same. So I don't need to write them twice. I can just do one of them because they're the exact same. So I will go x minus 8 equals 0. I move my 8 over, and x equals 8. I don't need to write 8 comma 8. 8 works out at just 1, okay? All right, so that was easy trinomial. That's the one you use the most. Now this next one I believe is going to be a hard trinomial, which is why I picked it, and I may be off camera, but as long as the board is in focus, we'll be all right. So 9 is the only thing that needs to be moved over, because this is positive, and that's a negative 9, so I need to add 9 to both sides. So when I do that, I get 4x squared minus 12x plus 9 equals 0. Okay? Now, 4 is a perfect square, x squared is a perfect square, and 9 is a perfect square. So this could be a perfect square trinomial. If it is, if I took the root of this, which would be 2, the root of this, which would be 3, and I multiplied those together to get 6 and double it, if it equals this, then it is a perfect square, and this is a perfect square. So I don't even have to do it hard trinomial, but I can. So I'm going to do this perfect square trinomial, and then maybe I'll do it hard trinomial just to show you both ways, to remind you how to do a hard trinomial. So this, now that I know that this is a perfect square trinomial, that means you're going to get the same parenthesis twice. You can write one parenthesis with a squared, and you take the square root of the first term. So square root of 4 is 2, square root of x squared is x. You take the sign of the middle term, which is a subtraction, and then the square root of the last term, which is 3. So now it's like I would write those twice, except for I didn't, and I'm going to set 2x minus 3 equals 0. I'm going to move 3 over. I'm going to get 2x equals 3, divide by 2, and x equals 3/2 or 1 1/2, however you want to do it. Okay? Now, I'm going to do this problem the hard way too. Let me erase a little spot real quick just to show you. I don't know where my towel went. Just to show you, in case you run up on a hard trinomial in this, which is possible. If you learn the shortcuts, that's great. It's going to save you a lot of trouble when you're about to find out that. But if you don't, you can always do it. As long as you know the easy and the hard trinomial, you can always do them that way. So I'm going to rewrite this problem. After I've moved the 9 over. Okay, so just this part, because I'm just going to show you how to factor it differently. We used perfect square trinomial because these are perfect squares. Okay, but if you didn't know that and you had to do a hard trinomial, the shortcut we use instead of the process of elimination like the book wants is that we make a new middle term. So you multiply the first and the last term, all right, which is going to give us 36x squared. You bring down your first term. You bring down your last term. And then you say what multiplies to 36, which is positive, and adds to negative 12. So what can I multiply to 36 and adds to negative 12? Well, let's look at the factors. 1 times 36, 2 times what, 18, 3 times 12, 4 times 9, and 6 times 6, right? Which one of those is going to make a 12 if you added them, right? It's going to be the 6 times the 6, okay? Well, if this is positive and that's negative, they both need to be negative. So I'm going to write negative 6x and negative 6x, okay? If I multiply negative 6x times negative 6x, I get a positive 36x squared. If I add them, I get the negative 12x. So now we have 4 terms, and we do what we call factor by grouping. We put them in parentheses. Okay, then we common factor each parenthesis. So 4 and 6 I can take out a 2. And then x squared and x I can take out an x. So 4 divided by 2 leaves 2. X squared divided by x leaves an x. 6 divided by 2 leaves a 3. And x divided by x leaves nothing. If there is a negative out here, you have to change the sign in here. So I need to remember to change that to a minus. 6 and 9 have a 3 in common, and this one doesn't have an x, so I can't take one out. All right, and then 3 goes into 6 2 times, and there's an x there. Remember to change that sign. And 3 goes into 9 3 times. Now, whatever repeats itself, if it repeated itself, you did something right. That goes in one parenthesis. And then whatever's on the outside, which is usually not the same thing if it's not a perfect square trinomial, goes in the other parenthesis. So you can see this and this are the exact same thing. This is just an expanded form. And then you would solve it, okay? So you can use every method that's possible on these, okay? If you know the shortcut was a lot shorter, okay? If you don't, go ahead and do it the hard way. All right, thanks for watching. Have a good rest of your day. God bless.